Hello, everyone. We're recording. This is the, what is today? It's the February 13th, 2019 edition of API Machinery. If everybody looks especially happy to see you all, it's because the weather outside is terrible here. Well, relative to Sunnyvale, usual weather. Mike, would you like to start?
Okay, sure. So I sent an email to first to the instrumentation SIG because that looked most on point, but I also alerted this SIG, and then someone in turn alerted the app SIG. So it seems to me we've been missing a bit of important observability in the Kubernetes control plane and things built in that style. And in other distributed systems that are built out of RPCs, this is solved by stuff like open tracing. But it seems to me that's not necessarily the right fit for the Kubernetes control plane because it's not built out of RPCs. So I tried to think of the right way to do this. So I sent a proposal to the instrumentation SIG. Got a reply from someone who had opened a KEP for how to do tracing on the kubelet. He's mainly thinking about the kubelet and a little bit about the scheduler. And I replied, I put a comment in that his PR there about why I think spans are not the right conceptual basis. So I thought that, it would be interesting to discuss with this group as well, obviously, since it's a kind of a generic principles issue for a control plane and thus API machinery. So the way it seems to me is the way the Kubernetes control plane is built is it's built out of state rights. We strive to write our controllers in a level-based way, but this does not deny that there are edges. In fact, of course, there are edges, and they're very important to performance, and we care about the edges. So each edge is a right to some state, and generally when a controller does that, it is based on what it read, that is to say earlier state rights, whose effects it read. So it seems to me the right conceptual basis for performance observability, you might call it tracing, but that might mislead people, is basically capturing these rights and these relationships between them. It also seems to me that the same instrumentation that would capture these, the same basically calls out of the controller code to record their rights and their relationships, that could also drive automated production of latency metrics, higher level latency metrics. So I don't mean, of course, we already have the latency metrics that come out of the work queue, but those only capture what happens one iteration in the work queue, right? The higher level latency metrics that are interesting. And in fact, in my own performance work, I produce such metrics in an ad hoc way. This is the latency from one state right to a consequent state right. So if we're capturing those relationships, this could produce automatically these higher level latency metrics as well as the observability data. And of course, it's been observed that actually capturing and saving all of this data, just as with traditional tracing, that's a lot of data and you don't necessarily want to do it all. It seems to me there are, in some sense, 3 levels at which this might be done. One is maybe doing nothing. One is the sort of the full instrumentation, keeping and propagating all the information. And an intermediate level would be to record in the objects the times of the state rights, but not what they depend on. That would be enough to enable the production of these higher level latency metrics. And it would be of intermediate cost. So that's an outline.
I didn't follow one thing there, which is why is the time without the things that went into the computation? How does that help you?
So let's take an example. Let's just look at the gross outline of the lifetime of a pod. So somebody creates it, and that's recording the creation timestamp. Then the scheduler gives it a placement. That is not timestamped anywhere. And then the kubelet goes ahead and implements the thing. And the result of that is not timestamped anywhere. But if, for example, the state right from the scheduler, if we just captured the timestamp of the state right from the scheduler, then we could automatically produce latency data, latency latency in the usual Prometheus style, of the latency from when the pod gets a placement to when the pod is actually implemented.
Well, I've got great news, which is that the server-side apply change is actually automatically going to do that.
Oh, excellent.
It is going to record, we're recording the field managers that are changing fields, and to handle the case where somebody's changing fields repeatedly, we're actually recording a timestamp along with that and which fields they changed. So you'll be getting that data and a little bit extra on top of it.
Now, does this apply? Does this come out only of server-side apply, or does this happen for all updates?
It happens for all updates. Yeah, apply affects the update path as well.
Excellent. Yeah. Okay.
So yeah, that'll basically give you that for free.
Okay. So that's a leg up on the overall proposal. So I just wanted review from the group. Is this making sense? Do they think we should do something based on spans instead? Just what does the group think?
I definitely agree with the first point you made, which is that tracking RPCs is not particularly useful in the Kubernetes control plane construction. Yeah, because what's interesting is what triggered things. I worry that the set of triggers will just grow unboundedly over time until it encompasses every object in the cluster.
Well, so I'm proposing, what I would propose is that controllers explicitly record individual relationships and not the transitive closure. Mm-hmm. Of course, the transitive closure grows over time, but the data that's recorded is individual relationships. And also, as the example of the scheduler shows, I think it'll be critical to be able to summarize. Right, the scheduler makes a decision based on reading all the nodes and all the pods, and we don't want to record all those relationships every time it writes a decision. So we need to be able to write a summary.
So for some of the problems you described, it seems like events, although it's not very useful today, but I think events can address some of your problems.
Events could potentially carry this data if they were able to carry it in a sufficiently structured way. One of the things I did not discuss at all is how it's for most instrumentation there are it kind of factors into a few phases, right? You have to instrument the code to kind of inject the primary data into some kind of an instrumentation framework in the local process. Then there has to be some kind of a collection that collects it from all the processes, and then it gets stored somewhere and used. So on those latter points, one could, for example, imagine using events as the way to get that data out. I would think the primary instrumentation should be with an API that's appropriate for the content, rather than just ad hoc stuffing stuff into events. I think we should have a purpose-built API for it.
I don't know that I go that far, right? Like you could go a long way with a context that gave you an object you would, right? I mean, we could invent an API on top of that, but context is already a thing in Golang, and it would seem to be pretty. You could go a long way with the context.
Yeah. Well, context. Oh no. Look, I completely agree that actually context will play an important part in conveying the information, but context is only going to convey information. There needs to be points at which a controller says, "Okay, I'm making this state right based on those things I read." And that's a new kind of data that we should have a purpose-built API for expressing. Yes, it may pull some things out of context in the course of doing that. It may put some things into context, but the primary new data should have a specific API for it.
So I don't know if we should go too in depth in whether we need an API or not in this group. I think that's a good design doc cap thing to talk about. I'm very interested actually in like that first layer of interactions. because I'd like to use that to compute a number for our system, which is like, I'll call it the R value, the average. Given a particular write, on average, how many other writes does that imply throughout the stack? Which our system has a property, if that number is below some threshold, it will settle eventually, and if that number is above some threshold, it will continuously write more and more and more changes, and it can explode.
Yeah, I think I know what the threshold is.
Yes. If we had this data per object, we could actually do like Monte Carlo MCMC simulations and like actually get a much better understanding of how information propagates through our system. Because it's like basically a conditional probability change.
Yes, I agree. There are other things one could use as well. One could also look at these latencies. They're in some sense, in part, a measure of the performance of the control plane, just in shuffling information around between controllers. And I would like to see metrics on that coming out of our regular testing.
Yeah. Okay. Cool. Let's. I guess. Any last comments on this?
Not
All right.
me.
Maybe you can add a link to the notes, so people can know where to go to follow up on this conversation.
Sure. Yeah, it's in the email. I'll copy a link into the agenda.
Thank you. Perfect.
And I'll try to add, I guess I'll continue down this path. I'll actually propose an API.
Sounds good. That could be very exciting. Okay, next we have a lot of KEPs to talk about. I hope most of them will not take very much time. I actually want to save the most time for the one about control plane fairness. So let's see how long the others take. First on the list is Wojtek's KEP to add bookmarks to watch. Wojtek, do you want to give us a 2-minute summary?
Sure, I will try to be fast. So the motivation is that we would like to avoid unnecessarily processing the same watch events that we already processed for. So the context is that when the watch is observing only a small percentage of objects, then we don't really have a way to let the watcher know that we already processed some stream of events for that, but there wasn't anything interested in that. So
Can you be a little clear on what you mean by we and watcher? What parts of the system are you referring to?
So I mean here API server. By watcher is like someone establishing a watch.
Yeah, a client with an active watch.
Yeah. So so I'm lost what I.
Yeah, I'm lost. I mean, I thought the client uses a resource version to precisely demarcate.
Yes. So it is using. Sorry.
The problem is if the watch generates events very infrequently, like you've got some restrictive filter. Okay.
Yeah. The problem is that the watch will time out at a point where the client has the last resource version the client has seen is very old. So when it tries to ask to pick up from there, that's too old and has to start with a relist of everything.
Yes, and unfortunately, because the filter is very restrictive, it's a very expensive list.
So if you mean back, it could mean one of two things. It could mean either you have very stale data, or you have very current data, and there was nothing for you.
Right. Okay, I understand the problem. Thank you.
Yes. So it doesn't only have to be list. If it's like even if it's like within history window, and it's still sending that resource version, we still need to process a bunch of like watch events that happen in the meantime that we already may have processed when it was like previously established.
Okay, that part. Oh, by we you mean the API server?
API server.
Yes. So the API server is going to refilter again. Yes, that's right.
So that's the motivation. So what I'm proposing is to introduce what we call like a bookmark. This is like a new event type where that will give us an ability to say that we already processed all the watch events up to this resource version, and there is nothing interested for you.
Right. It just conveys a new resource version.
Yeah, pretty much.
Yes.
Yeah. So
Very
to
good.
make it like compatible and backward compatible, we will be like encoding it in the object, because like the watch event contains inside like the runtime object. We will be just encoding it in the object, but that's like more of an implementation detail. And
The important thing there is that clients must opt in to observe this.
Yes. The important thing is that like in order to make it backward compatible, we will make it, as Daniel said, opt in, because if currently it would break like existing clients, like for example decoding, like the official decoding client like will break, like it doesn't understand this and it will like fail and stop the watch. Yeah, so I think that's mostly like the proposal. Like regarding exact implementation, I think there are a couple options. We can do it periodically. We can try to do it right before like the watcher is timing out. I think those are like a bit of implementation detail. We can decide it a little bit later, but yeah.
And I was just
periodically.
I was pinging Jordan background. I think like we should definitely think about super high cardinality or super high numbers of watchers and the impact on the system if that's not already there. Like I know systems that have 10,000 active watches at any time, and so it's just like we'll probably want to switch to bookmarks for those cases, but just
if there's no guarantee of how often you get a bookmark, you get to choose how frequently, and we get to arbitrarily decide when and how we're going to do it. Maybe you don't even bother with watches that are continuously getting events or that got any event in the past minute.
Yeah, this should be a very low bandwidth thing. I'm actually not worried about it. We can also like an easy rule is like not unless you haven't had an event for a minute or like
but then that's 10,000 timers, and timers are actually fairly expensive. I'm not saying we shouldn't do this. I'm saying
I think you don't actually need a timer because the event is going through the filter already. So
can the API server cache a key based on the filter and the last observed and the last matched one?
You know what's interesting is we might be able to get away with just sending the bookmark event a couple of seconds before we time out the watch.
So that's exactly what I did in my POC. I did a POC for that, and that's exactly what I did. I was sending an event like 1 second before like the watch is going to timeout, and it like helped by like 40x or something to this number of like
I'll just say like the only thing I was really worried about in this proposal was super large number of watches and the unanticipated behavior of, we sent a bookmark event to 10,000 watches at all the same time and the API server used up all its memory and died, which caused a thundering hurt. That kind of stuff, not the value of the proposal.
Yes, so my main motivation is like to help like those large clusters with a large number of watchers. So that's something that I will definitely keep in mind.
Okay, I'm very inclined to just approve this as soon as the meeting's over, because I think it's relatively safe as these things go, and the impact seems like it should be very large. So
and we are not targeting 114. We're talking about 115, right?
Yes.
Yeah. Sounds good.
Is
thank you.
Stefan, Michael, or Lukasz on?
I'm here, Stefan. Just a reminder about the cap out there about K-Flag. Michael wrote that and had heavy review, and we want to go forward with it. It's not that critical because it goes into experimental inside of component base, but we want to move that forward and iterate on that.
I wasn't clear why it wasn't just going to be a different repo.
It's not a different repo. We start in component base.
Yeah. I mean, it's logically separate, right?
Yes. When we're happy with it, we might separate it out.
We don't have a great track record doing that.
Yeah, I would prefer to separate from the beginning.
I mean, I would worry about accidentally growing dependencies on the other things in component base. It's not that that's necessarily the wrong spot if you always wanted to live there, but I think
what is easier that you can keep changes in one repository without go depths all the time. So the cap says after experimental, we will move it. And maybe just put a comment there that you prefer an external repository. I think then we have it.
Okay. So this, the request here is that David or I go review this.
Yes,
I don't
it needs
have any
your approval.
really. Like it looks like a new flag parsing wrapper. It's not a hugely significant choice one way or the other. We would end up dealing with some opinionated hierarchy chains, I think, as I understand the proposal, to try to map what the kubelet did during its transition from flags to structured config.
Yeah, it's a clean way to reapply flags to config structs without side effects.
Is this actually a SIG API machinery?
Well, we own the plumbing of the components. That's why probably.
I was about to ask about that one. This is Maciej from SIG CLI.
Yeah.
And I was interested in why it is under SIG API Machinery and SIG CLI was not involved in this.
Hey, we'll be glad to hand over to you, I think, unless Daniel.
Yeah.
Well,
no,
I'm just saying that probably kubectl will be the first major consumer.
kubectl was excluded. I mean, it might be a consumer of base, but the server bindings are the ones we look at.
Because the goal is to be a wrapper that allows binding and a hierarchy of bindings. Like you get this from a flag, or you get this from config, and one can override the other. And the CLI has no need to do that because the CLI is just flags.
Yeah.
Well, in that case, I tend to agree that it should not live in a separate repo because it will confuse people. One way or the other.
Should we have a discussion over Slack or in SIG CLI on this?
I don't think SIG CLI is the target audience for this piece.
It's the right place, but we can postpone it into the cap. We have a cap to discuss there. Just comment.
Okay. Yeah. Sorry, I have not read this cap. This actually appeared on the agenda after we closed the agenda. So sorry, I haven't actually read this. Okay. Let's talk about control plane fairness. Let's see, the cap actually goes to a document. The document goes to a document. Had a very kind contributor draft this. I think he can't be with us today because he's in China and this is not a good time.
I've been working with him, so I can relay a lot of what he says beyond what's in here.
Yeah, would you like to give the overview?
Okay, so yeah, this is responding to something we've discussed before. So the proposal is to say what we're going to do is take the existing in the chain of handlers in an API server. One of them is applying a concurrency limits. There's two concurrency limits, one for mutating requests and one for non-mutating requests. And the proposal here is to extend that. Currently, they do simple traffic policing, which is to say a request is either accepted and immediately started or it's rejected. The proposal is to add some traffic shaping to achieve some goals. Really, we have two sorts of goals that we've been talking about. And one is sort of system protection goals. We want the system to protect itself from workload and from out of control components within the system. And the other is in at least in a multi-tenant system, you want to have some concept of tenant and fairness between tenants. And as you probably know, for me, I'm interested not only in Kubernetes, but other systems built like Kubernetes with the API machinery. And I definitely have some multi-tenant scenarios. And so that's one of my concerns. People in this group tended to start more with the system protection, but I think the intent is that we should be able to accomplish both. They're essentially the same kind of thing. They're protection of one form or another. So the proposal that this contributor originally brought phrased this in a way that I recognized as equivalent to the way VMware expresses scheduling constraints. So the idea is that the requests are classified. So at this enforcement point, requests are classified according to some predicates that identify which class a request belongs to. And it's classified based on things you can tell looking at the request when it arrives. And this does not apply to long-running requests like watch and connect, because those don't have concurrency limits anyway. This is for the things that have concurrency limits. So the first step is to classify it into a class, and then the classes have scheduling parameters, which I recognized as the scheduling parameters VMware has been using for eons, which they call reservations, limits, and shares. Let's see, Clayton was saying something.
Yeah, I mean, I spoke with Yui when he started this, and we modeled it on TC, right? So when you model it on TC, it actually tries to match your request with a class, and we have the additional piece of choose that based on your subject in addition to the rest. And the subject matching will be the primary classification. At least that was the way it was initially sketched. Be the primary classification, and then from there you can have the additional limits, right? So you get the information that authorization gets off a request before you parse the body to be able to make a decision about whether you have an assured limit, whether you have something less than your max capacity, and then whether there's just slack after that, right?
So TC is like C groups, and they have, in VMware terms, they have limits and shares, but not reservations. And the proposal that was brought here has, the original term here was assured amount, and that's equivalent to the VMware term reservation.
Yeah,
Okay.
we definitely need to ensure that some system components get the QPS that they need.
So actually, I think that one of the most productive things to really discuss is what we really, kind of be careful about what we need and what we want, right? So the proposals here really talk in fairly simple blanket terms about system versus workload. But I recall from our earlier discussions, there was a lot of concern with, well, what if, one of the controllers just goes crazy for some reason? So we're talking about protecting part of the system from other parts of the system as well.
Yeah, I interpreted the proposal as, like, those were just two examples of the sorts of things the sorts of queues that you could have. I think within the system bucket, we definitely need more than one queue, right? If somebody brought up the example of leader election, like that's higher priority than other things. Yeah.
Yeah, it's just a matter of how you match the classification, and assuming you do first one hits wins.
Well, so yeah, I think the best way to do it is probably with a priority sort of scheme. So we let people write predicates, and we can have overlapping predicates, but each predicate for each class has a matching priority. So you look at all the classes whose predicate matches the request, and then with the highest matching priority, that's the one that you consider to actually be the class that you want to work with. And yeah, we want to be able to use the authenticated information that comes out of the authentication handler, which is indeed earlier. We want to be able to look at the, the HTTP attributes of the request, what it's manipulating. For things that are manipulating resources, we want to, understand it in resource terms, verb, namespace, name, subobject, that sort of thing.
Yeah, the important thing is, like, it should be very cheap to evaluate which bucket or which queue or whatever the request comes out of.
Actually, that's an important point that I didn't get a chance to write anything about. But if we take a simple list of classes and match against the list, that's going to perform unacceptably badly in a seriously multi-tenant situation. Now, 20 years ago,
our matching ability, and I don't know, we've shown that our ability to match is actually pretty darn good, right? Like, figure we do that on every request for RBAC using the same attributes.
Still, the number of things that are matched against in RBAC is much smaller than the number of tenants in a multi-tenant system. Right? You go to a multi-tenant system, you may have thousands of tenants. We don't deal with thousands of roles or bindings.
You're expecting to give each like namespace or whatever in your system a separate queue?
Yeah.
Yeah, I don't want to block this design on a maybe we'll end up with thousands, right? Like, this has utility even just for us as it is today.
Okay, yeah, I'm not, well, I think we don't have to have a blocking problem here at all. 20 years ago, people working on message brokers figured out technology for fast matching of a message against a lot of subscriptions, content-based matching. So there's technology we can pick more or less off the shelf to do fast matching against a lot of conditions.
Yeah, it seems like given a list, you can construct like some sort of spanning tree or something that
a decision tree. Yeah.
Okay, so yeah, decision tree. Yeah, that's better.
Right.
Term.
Right. That's the idea. Is this technology is about maintaining a decision tree that'll quickly classify.
Yeah, I guess I was thinking we would have like 10 buckets by default, like order 10. Yeah, if we have like tens of thousands, then a linear search is not going to cut it.
I think linear search gets us a long way, and we can look at something better later.
Well, look, this is a simple quantitative thing we can experiment with and find out. My point is that if linear search is not good enough, there is better technology, well established.
Yeah. Yeah. Okay. How far along how close to actually putting out a KEP do we think we are?
Well, we
like
have
the design that was out there.
So regarding the design, I think it has too much details. Is it possible to extract the implementation into a more higher level description?
Well, that's why we were looking at two KEPs, actually. Yeah, the original doesn't really have an abstract description of the behavior or the interface. It just dives directly into the implementation. I tried to write a version that focuses on the the behavioral description and the interface, and I did not write down an implementation.
I think the details kind of matter. I guess I look at the details and say that they matter to the point where it's like, do I believe you can actually go off and implement this?
I'm sorry, what I meant is actually I did outline the implementation. What I did not do is exhibit the scheduling algorithm. I had been hoping that and I have kind of an answer there, so that needs to be updated. So since what VMware does is ancient, I've been hoping that we could just find a published scheduling algorithm that does it. I actually haven't yet. What I would hope we don't actually have to invent a scheduling algorithm. And I did actually want to raise here a question. Do we really want to phrase it in this way? There's another way of thinking about it, which is priorities. And I wonder if priorities would be an acceptable or superior way of approaching the problem. Maybe priorities with some kind of fair sharing within each priority level.
Okay, sounds like we still have some more thinking to do on this. I'm
going to say that if there's an alternate proposal, I would want to see it in a level of detail similar to what Yui has described. Like, I don't want to hold this just because maybe there's something else out there. I would want to see that something else concrete. Yui has a clear, actionable plan that solves a legitimate need in our control plane, and it looks like it is viable and implementable.
To that, I would add I'm pretty interested in seeing a design like accepted by the group this quarter so that we can work on solving this, because I think it's going to rapidly become a very important aspect of our system.
So I'm going to say if there's an alternate design, I'd be looking for this level of detail, and I think I'd like to see it opened. Otherwise, I would, or a doc for it. Otherwise, I would encourage UE to write up a KEP and open it and against the enhancements, and we would continue the conversation there. And yeah, we can move the implementation out into a separate repo that gets linked. Was that Roy? Sorry, not Roy. The GitHub handle who had asked about that. Yeah.
Okay, we have got a fair amount of stuff to go through, and I really want to leave time to watch Antoine give us a demo of server-side apply. So I think we should keep going. Chow, do you want to give us?
Yeah.
This was very simple change, and
the cap itself is simple, but I don't know how much background I need to give here. So I assume everyone is familiar what storage version is. It's basically when the API server presents your data to etcd, it will encode it in a certain version. Like for deployment, you will always, so a 114 API server will encode it into apps v1 and then present it in the etcd. And we have a problem when you downgrade your API server. If your existing data in etcd is encoded in a different version than the default storage version, after a few downgrade, you might your API server might not be able to interpret what's in the etcd. So we need to do a migration whenever there's a version skew between the etcd data and the default storage version. We have already implemented the migration mechanism. What we lack is an automated migration trigger. For that, we had proposed to expose the default storage version as a hash in our discovery API. I already have an open pull request to implement that. And this CAF is specifically about how to use the exposed storage version hash to automate the migration. The basic idea is that we will have a custom controller that's periodically pulling the discovery API. It will keep record of what the storage versions are. So it will know what are stored in the etcd and what's the current default storage version. And if there's a skew, it will trigger the migration. The caveat is that because this is implemented based on polling, so if the storage version has changed multiple times within the polling period, the controller will not see that. It will miss the intermediate changes, and it will have inaccurate record of what's going on.
Yeah, basically, if you roll forward, roll back within 10 minutes, you need to.
Yeah, you need to restart the record tracking yourself. Otherwise, it's.
I'm sorry. What?
There is a generic. Let me explain it this way. There's a generic problem in our API server, which is there's no push notification when a schema is changed.
Right? Yeah. No. I'm just confused at the idea that if something changed, if you roll forward and roll back, somehow there has to be a change and an unchange. I'm a little just confused.
Yeah, roll forward, roll back is maybe not the best example. If you roll forward twice in rapid succession, then you have a problem.
Yeah. Well, presumably, if you roll forward twice in rapid succession, you can still convert, from what's stored to what you want. Otherwise, you've just hurt yourself.
I think it depends on which exact two versions you go through quickly.
Well, I mean, it makes no sense to go through two versions so quickly that you make old data unreadable.
Yes, therefore, in fact, I don't think that this is going to be a harmful limitation, but it is noted here.
It's not that old data becomes unreadable. It's that new data in the newest version could be unreadable by a version 2 levels back.
Or 2 levels up.
All right, the details are in the KEP. We're running out of time, so I think we should move on. If that sounded unusual, please go take a look. I already approved it, so we can always change it though. Okay, and last but not least, Howe has written a KEP about publishing OpenAPI for CRDs, like including the CRD specification in our in our main discovery document.
This is the work we actually started, or he actually started like 3 months ago, right? Just missed the release.
Yeah,
Yes.
that's just formatted in a very nice KEP now.
Yes.
I approve.
Because we checked it in the enhancement for
Yeah.
Yeah, we already talked about this one, so.
Yeah, I asked for one tiny change on it, but I'm probably going to approve it any minute. So
yeah.
Yeah, with that, let's give Antoine the floor to give us a server-side apply demo. I'll stop sharing so that you can figure out how to use Zoom. I will stop sharing. Oh, stop sharing. There we go. Okay.
It's good. Okay, I'm going to demo server-side apply, the current status. It's going to be pretty simple. Let's do it. Okay. You don't see? How do I zoom? I can zoom.
Oh, that's fine.
Okay, I've set up K to be an alias for my kubectl, which I just built, and I have I'm running against my own version of Kubernetes right now, and it's using my my kubectl version. So let's see. We're going to try and apply a deployment. Maybe I'm going to show the deployment. So it's a simple deployment, and Nginx, not much to say about it. Let's try and apply it. I'm going to mention that this is going to go directly to the patch endpoint, not to the create endpoint. And so this is creating the deployment. We can now look at the deployment that we've created. And what's new is this massive manage field at the top of the object, which has the list of people who modified the document and when they did so. So we can see, and the version. So we can see, for example, that what we applied is this set of fields. And so currently it's being owned by the apply manager. And we can see also that the Hypercube, because I'm running the local cluster, is owning some of the status fields, for example. And it has done multiple changes, so we can track them. And there is the date for each of these changes. So we can see all the fields that are owned in this manage field. Now we can pretend to be a HPA, for example, changing the number of replicas.
Horizontal pod autoscaler.
Yeah, yes, let's change the number of replicas. I'm going to use patch, and now we can look at the object again and see what happened. And so we can see that the kubectl manager just updated the object and now owns the number of replicas, which is no longer in my apply things, in the set of fields that I applied. So it kind of grabbed the ownership from apply. So one of the consequences of having lost the ownership of the field is that if I'm trying to apply again, now I get an error saying that I don't own the field anymore. It's been taken by kubectl at this very specific time. And we have the list of fields that I don't own anymore. One thing I can do to mitigate that is to run fast conflicts, which is going to say, hey, I want to re-grab these fields, give them back to me. And if we look at this again, we'll be able to notice that kubectl is completely disappeared from this list of managed fields. It doesn't own anything, so the managed field set is completely removed. And it's back to, I own it now. And it's been set back to 3 here. That's it.
Super nifty. I want to so that section, as you noted, is massive. However, if you compare it to the last annotation, the last applied annotation, at least the section that you applied is as small or smaller. Is that true?
I think it is. It doesn't look like it because it's YAML.
And it's all spread out on multiple lines.
Yeah, in JSON it would be much more compact.
Yes. And the thing is, like all the other, we now have entries for other things in the system that have set items. So those are spelled out also.
It should also compress well, although I know compression still. Did we ever actually even land that? I don't think we did.
I don't think so. Yeah.
Yeah. It would compress well. So it's like if we have a problem with this, like this seems like a relatively minimal format. I would say we should just go make compression work again.
Yeah. Yeah. We thought fairly carefully about the format to make sure that we didn't repeat things a bunch of times unnecessarily and therefore expand the object more than necessary. We have some ideas for keeping this amount of data down even more if it becomes a problem.
Yeah.
Yeah. I mean, I think the thing I'd be most worried about is humans trying to edit this, or slightly people who think they're clever but aren't. Or maybe that's a harsh way to say it. Someone who thinks that they understand the format and they miss a wrinkle and they try to write a tool that changes it, then blows up all of creation. That's my biggest.
I didn't think we actually accepted changes to this thing.
So we do. And so we kind of have a fallback strategy. If you're trying to edit it and you fail to do it properly, we're going to just ignore your changes. But if you're actually a smart person and can do it, then we're going to accept that.
Yeah, we might want to put like a big warning on the field, like we didn't really do this before, but like other generic fields that we don't want people touching, we should caution them in the Go doc to.
Yeah, that makes sense.
Yeah. I do think it's important to allow it to be manually edited.
Sure.
It allows like somebody who actually does know what they're doing and has a defect that they need to fix. It allows an escape hatch for that.
Yeah, if we're gonna kind of roll this out over time, just preventing people from getting too far into writing tooling to this until we've had a chance to verify it.
Yeah, I think that's a great idea. We have written a library that does all the logical operations on this that is reusable. I think the serialization code is in the main repository. Yeah, it's in the main repository, so that may not be super easy to reuse.
Yeah, we should do something about it.
Yeah, we can consider moving that.
Who's the most likely non-Go library consumer? Is it going to be a config management tool? Is it going to be somebody's cloud platform? Who's likely to come in and want to do this?
I mean, I would like to see people use this from all the native language clients, but they shouldn't need to understand this list. Like, really, there's no legitimate reason. Like, unless we've done something wrong, there's no reason for somebody to need to parse this list.
Yeah. Do we have fuzzing for this?
Do we? No.
Not yet. Not yet. Reminder, this is alpha, so.
Is this always returned? Oh, it's when you request it, it's returned.
That's
it's always returned, yes.
Yeah, it is always returned, but
there's no flag to flip it to say I'm not interested in it or I'm interested in it. Yeah, I was concerned about backward compatibility, and
we gate this with a gate, right? This is going in with a gate.
It needs to, the server-side apply feature needs to be enabled.
Yes.
Okay.
So the managed field has a schema in OpenAPI itself, right?
So it's using OpenAPI to decide what can be owned and what cannot.
No, I mean the managed field.
Yes, yes, it is part of our schema. The thing that is not part of the schema is the particular format of the names. It is a tree structure, so I'm not sure that you'll be able to learn too much from looking at the schema. And you wouldn't, the schema doesn't tell you how the string names are constructed. But other than that, yes, it is.
But other than the client, generated client should see this.
Yes.
Be able to.
Yes.
Yeah.
So for the timestamp, do we keep the history of a list of timestamps, or we only have one timestamp?
That's a good question. We only keep track of when the fields were acquired, And if you lose the ownership of these fields, the timestamp is going to disappear. So an HPA that would constantly, an horizontal pod as a scalar, that would constantly update the number of replicas, is going to have only one entry in the managed fields, which would be the last one.
Yeah. If we all got super excited about keeping timestamps of everything, as Mike suggested earlier in the day, I imagine we could permit keeping the last in modifications, even if they're currently empty. Like,
yeah,
it's conceivable.
Yeah, it's doable.
I'm not sure it's a good idea, but it's conceivable.
Yeah.
Does the timestamp aspect change no-op rights, or do we only update timestamps when you actually changed a field?
So yeah, we set the timestamp when you acquire the field,
which requires
the object to be modified because you acquire by modifying.
It'd be good to have knowing the history on we screw up idempotent rights so many times. It'd be good to have a couple of things that specifically call out idempotent rights.
How many times have we broken that?
6 or 7. Actually, yesterday I had to explain to someone because it was correct, and they were terribly confused that it was correct, which I thought was a success on our part.
Yeah. Okay. I'm pretty excited about this. We have an umbrella issue with a list of things that we need to get to beta and a few other things that we're going to do before the current release is cut.
Yeah, this is pretty huge.
It's in alpha. We're out of the feature branch. Yeah, so play with it. Let us know.
Yeah.
All right. And we're done with 5 minutes to spare. So thank you all for coming, and we'll see you in 2 weeks.